Welcome to Module 4 of PCC in Class 288M, and I'm glad to be bringing you Chapter 4, Implementing DHCP. So this will be one of the labs that we do in our course. So let's take a look at the objectives. We're going to describe the DHCP protocol, configure a DHCP server, which will be fun, implement DHCP version 6, which will be new to a lot of people, and configure DHCP high availability, so that way you can have failover from one to the other. So, an overview. DHCP stands for Dynamic Host Control Protocol. It's a component of the TCP/IP protocol suite. So it's used to assign an IP address. So if you've got a computer that's set to automatically receive an IP address, then it will look to the DHCP server to hand out that information. Now, DHCP can be installed on a lot of different things. It can be installed on a Windows server, of course, but it can also be installed on a router or on a switch or even on a firewall. The thing is, you want to make sure you don't have a DHCP server installed on more than one device in the same network, unless it's two Windows server working as a failover type of a pair. So this is what happens, and this may be a quiz question, so you might want to pay attention to this. You've got the DHCP Discover. So it's a packet that gets sent out from the client and says, hey, where is the DHCP server? The DHCP server says here, and I have an offer for you. The request happens, and then the IP address gets assigned. So it's a 4-step process. Then when the IP address lease, because when you send out these IP addresses, they have a certain amount of time before they get stale and they get dropped. So at the 50% mark, which again may be a quiz alert, when the lease is expired by 50%, the client sends off a unicast packet. And remember, unicast is 1-to-1, multicast is many-to-one. So unicast packet off to the server and says, hey, I need to get a renewal before my lease runs out. So if it can't respond, if the DHCP server can't respond, then the client will try 3 more times before it gives up. And then eventually that lease will give out and the IP address will drop. And then the computer will no longer be able to communicate with the network. Now, if you set a static IP, you don't have to worry about that because that never changes and doesn't need a DHCP server. And that's something that you did in Lab 1. The DHCP server role can be installed by using the add roles and features, or you could use a PowerShell command that you see here. After installing DHCP console, then you'll go ahead and go to Server Manager, go to Tools, you'll see DHCP Manager in the list. Now, a DHCP server has to be authorized. If it's not authorized, it cannot assign IP addresses. And that keeps you from getting a rogue DHCP servers on your network that hand out IP addresses you don't want them to hand out, and then it ends up getting clients that can't communicate with anybody. So here we see a DHCP server that is set up. However, you see the little red arrows pointing down, and that's because the server is not yet started or not yet authorized. So once those turn green, then you know that it's working. DHCP clients have no way of determining whether a DHCP server is valid. There is no security when it comes to the DHCP request. So that's one of the other reasons you need to make sure that your server is authorized. I've seen many networks be brought down because of a rogue DHCP server. And it's not usually because it's something malicious, it's just usually an accident that somebody maybe plugged in a wireless access point that turned out to be a wireless router, and DHCP server was turned on. And there's a lot of other devices that do that kind of thing as well. So when you create DHCP configuration, you create what's called a scope, and that has a pool of IP addresses along with other configuration. So you've got to have the scope name has to be created, a starting address and an ending address. You want to make sure that doesn't overlap any known static IP addresses. Then you have to have a subnet mask, of course, which we talked about in Module 1 when we talked about TCP/IP. It's got to have a lease duration. By default, it's going to be 8 days. That may be a quiz question, but you can certainly change that. I like to have it set to 1 day myself because sometimes 8 days is a little bit long if I'm going to be making changes to the network. So this is what a scope wizard looks like. There's a starting address, ending address, and our subnet mask. And the 24 is the CIDR notation, so it'd be like a /24, and you see the subnet mask matches that /24. Addresses can be excluded in a couple different ways. So you can have an exclusion list. This is going to be one of the things you'll be doing in your lab, actually. You can also create an exclusion range. So you can just have an individual IP, or you can have a range of IPs. So if say, for some reason you have a wide scope of IP addresses and they happen to overlap with some of your known static addresses, and you just can't figure out a way to make it work any other way, then you can just create an exclusion range and say, okay, between 100 and 102, exclude from handing those IP addresses out so nobody gets a duplicate IP. You can also set up a reservation. So for instance, a printer, you want that printer to always have the same IP address so it's easy to find. So you can reserve that printer to have a specific IP address using its MAC address. We talked about MAC addresses that are burned into the network cards when the cards are manufactured. DHCP scope can serve a single subnet, which is fine, but it can also serve multiple subnets. So if you have many subnets or VLANs in your organization, you can use the DHCP helper command in the switches and routers to say, look to the Windows server to get your IP address, even if you're not in this subnet. So for instance, you have a 192.168.1 and a 192.168.2 subnet. It can serve IP addresses to both of them. It can travel through the switch or through the router to the other subnets if needed when you configure it properly. There's also something called a super scope, and that's a special type of one or more member scopes, and it allows DHCP server to service multiple subnets on a single physical network. So this is really useful if you have a number of computers on a network that exceeds the original subnet size. So let's say your scope is set to 100 through 110, and now you realize, oh, I've got to add 10 more addresses. Well, you can use a super scope to extend that list of computers that you can actually cover for DHCP. Multicast scopes. So a multicast packet, remember that's many to one, is addressed to a group of hosts listening to a particular multicast IP address. So if you say, hey, your DHCP server is at this IP address, which can be a nice security feature, so that way it won't listen to IPs on other ones, you can set up this multicast scope. And so it assigns the addresses dynamically to multicast servers and clients using the Multicast Address Dynamic Client Allocation Protocol, MADCAP, which is a great acronym. So two common ranges of multicast addresses are administrative scopes and global scopes. So administrative would just be for administrative purposes, but global would be for everybody. Several different options when you create your scope. You've got server options, scope options, policy options, and reservation options. And those different options are all described here. So you can go ahead and take a look at these. All these slides are available in your content section under each individual module. So if I'm going too fast for you, then you can go to that slide presentation and look at those slides. I also recommend you look at those slides for the quizzes, because a lot of quiz questions are based on the slides. So if I'm going too fast for you here, go to the slide presentation one at a time until you find the answers that you need. Some common options when you set up a scope, besides the range of addresses, you want to set up the router. Basically, the router is the same as the gateway. We talked about the gateway in Module 1, so a computer can get out to the internet. So a router is the exact same thing. They just call it two different things, but they are the exact same thing. So the router gets you outside of the internal subnet you're in. Sometimes that means the internet. Sometimes it just means another subnet in your network. Also tells you how to set up your DNS servers, your name servers. DNS domain, so in our case, widget LLC.internal. It also allows you to set up WINS. WINS is something that's fairly outdated. If you have some really old clients that rely on WINS, say Windows 2000, Windows 98, Windows 95, first off, shame on you. Second, then you should set up WINS on your server so they can also be serviced. So here's how you can configure these options. You would just right-click on the scope, go to Properties, and you can tick off which one you want to add. So if you wanted to add a router, you would tick 003. You'd type in the IP address, click Add, and then Apply, and now you've got a gateway. So you can do that with, I think there's about 50 different options here. Most of them you're not going to use. So when performing DHCP server configuration, you can right-click the server node and you can choose a lot of different tasks. One of the most basic ones, or most useful ones, is backup and restore. So if you are going to, say for instance, move your DHCP server from an old server to a new one, then this is a great feature. You can back this up to a file, then you can turn off DHCP on the old server, go to the new server, and choose restore, and then turn that on and authorize it. And then that way, if you've got a lot of configuration, there are many subnets, many reservations, you don't have to go in and recreate all those, which could take a long time. IPv4 properties, this is the audit log file path. So if you need to audit what's happening on your DHCP server, there is a log file that's there by default. Now, what I really like is this conflict detection attempt. And I think by default this should be set to at least 1 or 2, but by default it's set to 0, which I think can be a real problem. So I would go in and you right-click on the server, go to Properties, and then you can go and see this Advanced tab. So the conflict detection attempts basically says, hey, before I assign an IP address to this computer, I'm going to go out and double check to make sure that nobody else has this IP address. So it goes out, does both address resolution protocol to make sure that it's not a reverse lookup, and then it does a forward lookup. If it responds to ping, great. If it doesn't, it'll find it by MAC address, and then it says, hey, nobody else has this IP address. I'm going to go ahead and assign it to you. If you set the conflict resolution to at least 1. So if you set it to 2 or 3, it'll just do a double check or triple check before it assigns that IP address. If you have it set to 0, it's just going to assign it whether it finds it or not, and I don't think that's a great idea. DHCP name protection. Use something called name squatting. That's a DNS problem that occurs when non-Windows computer registers its name with the DNS server, but the name's already been registered with the Windows computer. Now, you can't have 2 different devices with the exact same name. It causes all kinds of conflicts. You'll see pop-ups happen saying duplicate name on the network. Everybody has to have a different name. So there is name protection built in to DHCP. It prevents this name squatting from happening. And here is the Enable Name Protection option, which you can get by right-clicking on the server. Scope Properties has 4 tabs. You see General, DNS, Network Access Protection, and Advanced. So here is our Advanced. You can assign to DHCP, BootP, or both. So basically, DHCP is the protocol used for Windows devices, and BootP is typically used by Linux and Unix devices. Although some Linux and Unix can also use DHCP as well. It just depends on the flavor of Linux that you get. Macintosh, I believe, uses BootP. I'm not 100% sure. It might use both DHCP as well, but Macintosh doesn't belong in business networks for a lot of different reasons. So hopefully, whatever business you work at doesn't have Macintosh, and if it does, hopefully you'll get it. Convince the boss to throw those away because they're worthless. Configuring DHCP for Pixie Boot. By the way, I bought my mom a Macintosh. Fine, it doesn't belong in business. So configuring DHCP for Pixie Boot. If Windows Deployment Service, you can use that to send out Windows operating systems to computers using the Pixie Boot. So a computer boots up. It sends this PXE, pre-execution environment sort of protocol out to the network. It says, hey, is there a DHCP server and a Windows deployment server? If the answer is yes, it will get an automatic IP address assigned, and then it will look for that deployment server to get a new image. So you could take a computer with no image on it whatsoever, or a computer with an image that you want to format over it, and you can have DHCP help you out to reach that Windows deployment server to get a fresh version of Windows installed without having to use a DVD. So it's great. It installs it over the network. It's very fast, very efficient way of deploying new operating systems to new computers or computers that need a refresh. So there's the Pixie client string that you can set up on your DHCP server. DHCP relay agent, I mentioned this before. If you have multiple subnets, you want to set up this relay agent that automatically sends other subnets to your DHCP server. Without it, they won't be able to find an IP address if there's no DHCP server on that particular subnet. So you need to set up the relay to find the DHCP server where you want it to go to. So this is a little diagram of DHCP server. You've got DHCP clients, you've got the server in the top right, and you got the relay agent off to this bottom left. So basically the DHCP client comes down and says, hey, I need an IP address. Well, the DHCP relay agent is not a DHCP server. It's a relay agent. So it sends the relay off to the DHCP server in the top right, goes back down, the client gets its IP address, and off it goes. If you don't have a server and you want to use DHCP relay, you can do that same thing on a switch using what's called the IP helper command. It's the exact same thing. So if you want to migrate a DHCP server from one to the other, you can do it multiple different ways. You can do the backup and restore option. You could do the export and import option. So there's lots of different ways that you can get an old DHCP server to go to a new DHCP server. Now, some of the older versions don't have the compatible backup and restore options, so you end up having to use some of these commands instead. So, migrate server from server 1 to 2, follow these steps. This is step 5 and step 6. You might see that on a quiz, so you might want to pay attention to that. Troubleshooting DHCP. It is pretty reliable thing, but however, sometimes you're going to have an option, a problem. And one of those problems would be a client is not receiving a DHCP address. Sometimes it happens because there's a conflict. Sometimes it happens because the cable's too long. There's a problem, a fault in the cable. A wireless card isn't working right. Lots of different options. So there's some tools that you can use. There as reviewing DHCP server statistics. You can look at that log file. You can also use a third-party protocol analyzer such as Wireshark to see what's going on as well. DHCP server has something called high availability, and it allows you to have more than one DHCP server in several different ways. One is you could cluster DHCP. So basically if one DHCP server goes down, the other has the exact duplicate information on it, and it will, it's sort of be in a standby mode. It'll go to hot mode, and it'll start handing out IP addresses. Another way is to split the scopes. So basically, you've got two scopes on there. One is maybe 192.168.1, and then it covers addresses 50 to 100. And the other server covers addresses 101 to 150. So if one server goes down, then the other server picks it up. So that's another way. And then the third way is DHCP failover. So you can create failover inside the server itself using the failover option. So 3 different ways to all accomplish the same thing. So I just told you about the split scope and what that is. This sort of gives you the steps on how to create it. And then here's the percentage of split scope here. A lot of times you don't do 50-50 on these split scopes. A lot of times you do maybe 80-20, 70-30, something like that, where one server is the dominant server that has the most amount of IP addresses available. So this is the failover that allows two DHCP servers to share the pool of addresses. So you would just right-click on the server, go to Properties, and go to the failover and choose that option and say, hey, here's the IP address of the other server. And then it'll configure failover in that way. So configuring load balance modes, configure DHCP failover. As I mentioned earlier, you right-click the IPv4 node of the target scope, click failover, and then just walk through that wizard. And this is what it looks like. So you've got the relationship name, there's the server, maximum lead time, how long before it fails over. I wouldn't do 1 hour, that seems like a long time. Load balance percentage if you want to, and a message authentication. If you want to have a password between the two, you can have a shared secret, which I think is a good idea for security. And there's your hot standby mode option. So you can either have it hot or cold, depending on if you want to have them both working at the same time or one working and the other in standby mode when it's needed. You can edit or delete a failover configuration. If you say, hey, I no longer want to have this other server as my failover server, then you can go in and you can edit it and you can delete the one and you can add a new one. Covered a lot of ground here in DHCP. I think this will make a lot more sense once you go into your lab and do your DHCP setup. And I think it'll be very exciting. I remember the first time I set up my DHCP server on NT4, Windows NT4, and when it handed out an IP address to my client, I thought it was like magic. I was amazed that that it worked. That I got it to work right, and it's really not that difficult to do. There's a lot of great features to make it more complex if you want to make it more secure, but in its simplest form, DHCP server just works. So thank you for joining me on Module 4, and go ahead and get started in your lab, and I look forward to seeing you in Module 5.